Hello viewers, welcome to Sevivali Kalvi channel. Let us see the concept of half-wave rectifier by using Tinkercad software. So for that we are going to design the half-wave rectifier circuit. So we have to select this circuit button and we just click it. So in this design, we can go for create and click circuit. So new window will appear for designing the particular concept. So for that, we have to select what kind of components we need to place for this particular experiment. So initially, I have to select the breadboard. So I just drag and drop this breadboard here. So all vertical lines and horizontal lines are there. So in this connection, we have to remember this top two lines can be connected as a ground or plus VCC, that is supply line. So in this first rows are assigned as a negative, that is ground purpose, and the second rows are connected for plus VCC supply, and bottom first lines also can be taken for ground, and second line can be connected for positive lines. So apart from this, two segment of this breadboards lines are connected in dotted lines, and this horizontal lines are not interconnected with each other in these two areas. This top and bottom ground and plus VCC lines are connected in horizontal manner, but in this two segment areas, vertical lines are interconnected with each other. This five dotted lines of every columns are connected together, and this five column different columns of five dotted lines are connected together. So from this we are going to connect various components which is required for designing this half-wave rectifier. So I am going to take the basic components. So initially I need a resistor. So for that reason I just take resistor. And apart from this I have to take a very important component, that is diode. So for this purpose I can take diode also. So now I have to arrange this diode and resistor in a proper connection method. So here I just rotate this component diode. So this left hand side is terminal is the anode terminal, and this silver coating line is called as a cathode line. So this is the cathode terminal. So this is a two terminal semiconductor device, that is PN junction diode. So now this resistor can be connected here. So now these two are connected in series manner. So apart from this, we are going to give input signals to this diode. With the help of this input, we can produce the output. So for this, we can take a function generator and CRO. So first function generator can be taken place. We can just drag this function generator and drop it here and place it here. After that, we can take oscilloscope. So here I have to take two oscilloscope. One oscilloscope is for input and another is for output. So from this function generator, we can connect this diodes, and also we can connect this CRO, that is cathode oscilloscope, with this input. At the same time, if you change your input values with frequency and time period, you can monitor and display this signal in input side of CRO. Similarly, in output side of CRO, we can produce the output from this diode terminals. So now we can connect these all the components with the help of this wires and with different equipments like function generators and oscilloscope. Now I can take wires. So this wires can be connected as a normal wire, and here initially I can start from this positive terminal of function generator is connected with this anode terminal of PN junction diode, and another line I can take from this CRO. Now this positive terminal of CRO is connected with anode terminal of diode, and also the function generator positive line also connected with this anode terminal. Now we have to connect the ground terminal. So now I can rechange this color, because the positive terminal lines can be connected are represented as red color. So I can mark it as red color, and here I can take ground lines. I can connect this ground line with this. Now the resistor terminal also connected with one ground terminal. So for this purpose we use this line here also, and the negative terminal of first CRO also connected with this ground terminal. So now all the grounds are interconnected with each other. Now I can rechange this color black instead of red, because of ground line. You can differentiate which is positive line, which is negative, that is plus VCC and ground line. So from this you can understand this. So after that, in output side we have to take ground line, and again this is connected with this resistor terminal, and positive line is connected. Positive terminal can be connected in this cathode terminal of PN junction diode. Now I can again rechange the color by red, because it is positive terminal and it is negative, that is ground terminal. So now the connection portion is over. We can run the program. So without writing any program, we can run this program, and we can easily see the output. So in input side we have a function generator. So from this I can choose the amplitude value or frequency value, etc. Here I can choose 100 Hertz frequency by clicking this function generator. And if you want to choose only 2 volt or 4 volt, you can set like this. And if you want to make a DC offset value as 0 or some positive value, that also can be taken here. And which function signal you want to represent, that can be chosen here. Here I can take sine function. So the sine function can be enabled here. So because of choosing the low frequency, now the signal can be easily seen. So if you increase the frequency level, automatically the time period is very less, because both time and frequency are inversely proportional to each other. So at the time we can't able to see clearly. So because of this reason, here I have chosen this frequency as very low value. For example, 10 Hertz. So at the same time, DC offset value I assigned 0. So because of this reason, this axis curve, that is this is x-axis and this is y-axis, all four quadrants are there. This is origin point 0, this is a positive half cycle, this is negative half cycle. So the signal is started from 0 to 360 degree, one full cycle can be produced. So this is continuously produced. So this signal is called as a continuous time signals. And I have chosen the sine function here. So sine signal is represented in this example. If you want to choose a square function, you can rechange that by selecting this function. So now I have chosen a sine function. So in input side, we have displayed the sine function of signal. So now our concept is half wave rectifier. Now what happened here? The diode is connected with input signal is connected with anode terminal and output is connected with cathode terminal, and it will produce the half of the cycle of the signal, that is the negative half cycle is rectified and positive half cycle signal is produced. It is a concept of half wave rectifier by using single diode, that is the PN junction diode. It is a semiconductor device. In case if you increase this frequency or decrease this frequency, automatically you will get a corresponding output like this. So this is a half wave rectifier. So if you want to replace this name, half wave rectifier, so now you can change your name as half-wave rectifier. So this is actually half-wave rectifier designing without filter. That is without using any capacitor. Here we are using this circuit and designing this half-wave rectifier without filtering. In case if I want to use half wave rectifier. So in case if I want to use the capacitor and with filter, I want to measure the output of this half wave rectifier. Simply we do only one thing. We just remove this resistor and place the capacitor here. So you just go to this component area. In this all component area, we have a polarized capacitor. We just drag it and drop it. Because of execution, it is not working. So we just stop the simulation, and after that we just drag this capacitor here and place it. We just remove this and rotate this capacitor, because the connection should be connected properly. Now this is the area. So you can rotate this capacitor like this and move it in different places. Take the wire. Now this is connected with this line, and this is connected with this negative terminal. So one terminal of capacitor is positive and another terminal of capacitor is negative. So this portion is negative. So for this we just change this color. So now you can start simulation, and you can reset your DC offset value by lower value, that is minus level. Now you can able to see the output. Because of charging of capacitor and discharging of capacitor, you will get the output. You can see this difference of output. Because of wearing this values. You can increase this amplitude value or frequency value, and also your DC offset value. You try to reduce your value in terms of minus, so the charging and discharging of capacitor will be happened properly. So sometimes if you set this value and run it, immediately you will get output. So now you can see it. The signal is running continuously. So positive half cycle and negative half cycle. So one full periodic signal will be generated. So one clock period is called as a one full cycle. So according to this, the capacitor is charged and discharged. So whenever the positive cycle is enabled, that is from 0 to peak, positive peak goes, at the time the capacitor goes charging, and after that it comes to down, at the time the capacitor will discharge. So based on this concept, this uh, half wave rectifier can be generated the proper output, both with filter and without filter concept. I hope everyone understand this concept clearly. Kindly see all the videos and give your suggestions. Thank you all. Kindly subscribe my channel. Thank you.